Alright guys, welcome back. Now it's time for a challenge. So we take our system out approach and try to print out the encrypted or decrypted method. Regarding to XOR, it doesn't really matter because our input gets XORed with a value or a key. And then we have our output, which is encrypted or decrypted. If we take the output, XOR it back again with the same key, we get back our input. Therefore, it doesn't matter if it's an encryption or decryption method. Okay, however, we've got our application and we need to find out the secret message. We can see the secret message is not being printed. So I would assume that we have to deal with an encrypted text and we need to get the decrypted version of this. Okay, we can see the application underneath and yeah, the layout has been also improved. I promised this to you. So yeah, let's simply analyze this application and see how we can use the system out approach to get out the message. Therefore, we switch to our Ubuntu VM. And you can find this challenge in the section as an attachment. I have already downloaded it and it's called XOR encryption. So I take this app, put it into our well-organized apps directory over here. XOR encryption. All right. And now, yeah, let's simply take a look into this. So yeah, once again, we use JDX GUI, and let's see if JDX GUI decompiles it fully correctly or if there are some errors where we need to take care of. So JDX GUI, then we've got this log level and we also want to get the errors. Okay, let's see. Application is loading. So we click into the Android manifest XML over here. All right, let's have a look back into this. Okay, so far all good. Okay, in the Android manifest, we can see we do not have any certain permission. That's good. We only have one activity, which is the main activity, and that's the launcher. All right, let's have a look into the classes. So this is our main activity. Let's get back to this one. Okay, so here we have some problems, but these are not regarding to our code. Okay, so yes, it looks fine. Okay, so here we have our main activity. Let's see. We've got our onCreate, we've got setContentView, we've got a text view, and we also got XOR encryption, encrypt, decrypt. All right, and this is our message. So I would assume this is the encrypted version, and this one decrypts it. But afterwards we can see there's no return value, or at least we do not use this return value. So we never know what this decrypted message looks like. And this is the task we have to find out. Okay, so let's get into this. Encrypt, decrypt. We can see, interesting, this method gets a return value from type string, but it's not being used in our Java code. So therefore it gets thrown away at the Java side. All right, so this is a static method, encrypt, decrypt. It gets an input string and it returns back a string. Okay, here we have our key, which is app hacking. Okay, we've got a new string builder, so we've got a new output buffer. And here we can see we've got a for loop, which is based on the input length. All right, then we've got output append, and we take one char from our input and XOR it with the key modulo key length. Okay, and then we return it back. Okay, so if you deal the first time with an XOR encryption, I guess we should recap this a little bit. So I get out my graphic tablet and then we have a look into this. Okay, let's talk about this function. So we've got this function encrypt, decrypt. We have a string as an parameter in there. All right. So this one over here, this is our message, our encrypted message. Let's say it looks like this one over here. Then we've got a for loop, or let's say, okay, we've got a key first. So here we have a key. Key is equals, and then we've got single letters. A, P, P, and so on. So this is our key. Okay, now what we do is we take our encrypted message, this one over here, and we put this into this for loop. This means we take one char out of this and we XOR it with the first char over here. So this means this $sign gets now XORed with A. We do this for the length of this message. So we do this as often as this message gets input data. This is what this length at the beginning is about. Okay, now we've got this super strange looking part over here. And this makes sure, let's assume we've only got as a key 3 letters, these 3 chars. So that's the end of our key. But now we increase the counter over here, so we take the next letter from our message, which is the hashtag. We XOR this now with P. Then we take the next one, which is 1. We XOR this, we XOR this with the other P. And now we have a problem because we take the next one, which is S. And we do not have any letter left in our app key. This is why we have this modulo key length. This means if we run out of characters in our key over there, this one, we make sure to start at the beginning once again. Therefore, it doesn't matter how large this message is, we simply start at the beginning. So this one now becomes an A back again. So if we reach the end over here, then we go back to the beginning. And this is what this I modulo key length does. Okay, therefore it doesn't really matter how many chars are in there. For example, if there are more than on the right, it doesn't matter because the key length, the for loop of the key length will abort afterwards. So let's say our message only contains 2 characters. So this one is not available anymore. Then this first condition over here, int I is equal to 0, I is less than input length. So in this case, the input length defines how many rounds we take over here. And if the input length is less than the key length, it doesn't really matter. So the only problem with this one is that the key gets cut off, and in this case we do not have more than 2 characters. So our key is only 2 characters long, A and P. But that's also the case for our message. Alright, so this is what this function does. So now let's see where we can place our system out to get the decrypted message out. So let me clean this up. Okay, so we have different options. The first one is within this one. So here we have output to string. This means this method over here returns our decrypted string, and this will be stored in there. So before we return out of this, so let's say it looks something like return v1, for example, or v2, we just know this. So before we return out, we simply add our system out over here. System.out print line v1. By having this before the method returns out of this one, it simply prints out the encrypted or decrypted message to our console. And this is exactly what we want to have. But at this point, we also see some typecasting over here. So this output is from type, let's see, string builder, and here it gets typecast to string. So we also have to typecast it first, otherwise we are returning in string builder, and I'm not sure if this works. So this approach is working, but it's a little bit more complex. So let's have a look into the main activity, and maybe we can do it over there, which is a little bit easier. So I clean this up, and let's get back to the main activity. Okay, so here we can see we have our XOR encryption. Then we've got encrypt, decrypt, and our message, which is encrypted, but will be returned as a string decrypted. In this case, we do not have a variable assigned to this output, so the return value of this one. And we can see, it's not going to be used. But maybe we've got this in the Smali part. So at a first look, it doesn't seem like to be a valid option for us, because we do not have a return value there, or a return value that's being used. But let's have a look into the Smali code. Maybe the Smali code is a little bit different. So let's see. Okay, so I have decompiled this application and now we simply open the Smali file. Let's have a look into the main activity. Change this to Java. Okay, so let's see. We've got our main activity and we extend app compat activity. Okay, that's our source file. Here we can see we have an instance field from text view. Haven't seen this for a while. Then we've got our constructor, direct method. Here we have our public methods. Oh, it also counts for protected methods. Okay, so at this point, sorry on this, virtual methods are regarding to public and protected methods. Okay, then we can see we have 3 local registers and there's a lot of stuff going on here. But let's have a look back into the Java code. So let's see. Okay, so here we have the line numbers. If we left click, we can see, okay, these are the original Java line numbers. So we click once again. These are our line numbers, regarding to our Smali code. So we are not interested in this super on create set content view and also this text view. So let's try to skip this one and also this one at the end. So we are only interested in this part. Let's see if we can encapsulate this a little bit. So let's see, line 16, 17, here we can see, let's see, here we have our on create, set content view, find view by ID. This is all the stuff we are not interested in, there we go. Here we have our encrypted message. Okay, I told you to not only rely on those line numbers, but if we take a look at this right now, we can see, okay, here we have our encrypted message, it's being stored in v0. And if we take back a look, okay, this should match regarding to the Java code over here. All right, then let's see. Move result, what's the message? Text view. Okay, so this is the part we are interested in. This is line 21. And if you take back a look, this is exactly what this one does. Okay, and now let's see if we can use our system out approach over here. So we've got this string which is being stored in v0. Then we have an invoke static and here we can see nice. We've got a move result object into v0. And if you take a look into this, this is XOR encryption encrypt decrypt. So we are storing the result value in our register v0. But this one it's not being used anymore. Let's see. Yes, we simply have a name for this one which is encrypted, but it's not going to be used anywhere else. Therefore, the Java code throws this return value away, but not the Smali code. So the Smali code, it's like the matrix. We can see the whole code in there, not just the surface of this, which is shown here. Within the Smali code, we are seeing the whole code. And this one is super nice because we have a reference to our string over here. And now we can print this out. Okay, so first let's analyze this code over here, that we make sure that we understood this, and then we insert our approach. All right. Okay, so we are putting our encrypted message into v0. Okay, so v0 is holding our encrypted message. Okay, then we have invoke static. So this one is clear. Next we have invoke static. Invoke static, this means we have an argument over here, but now we need to be sure, is this now the this object or is it the parameter of our function? Do you still know what's the case for an invoke static? If not, please look this up. So is it this or our first parameter? Yes, absolutely correct. This one is our first parameter of this function. We can also cheat a little bit on this because if you take a look, so we are calling the method encrypt decrypt, and here we can see we are having a parameter in there. So this one is our parameter. It's from type Java lang string. And this parameter needs to be mentioned in our parameter list at the beginning. Therefore we know v0 is not the this object, it's our first parameter. By the way, invoke static never has an this object in there, because a static method doesn't need an instance to be called. It's just simply the class and method name. Therefore, yeah, we can simply remember this, or we can do our analysis on this to figure out what's the case over here. I like the second approach a little bit more because this helps us also for other instructions. Okay. So let's get this cleaned. There we go. So let's see what this does. Okay, so we are having here our XOR encryption class. XOR encryption. And now we are calling dot encrypt decrypt. Encrypt decrypt with our v0 as the first parameter. Oops, wrong color. Also wrong color. There we go. And we are returning back in string. Yes, so this is exactly what we have seen and analyzed in the Java code. Okay, next we've got this instruction, move result object into v0. This means our v0 contains now the return value of this function. And this function encrypts or decrypts our method. And this function over here returns the decrypted message in our case. Because we are inserting an encrypted message, and by calling this, we get back the decrypted message. If we put in our decrypted message into this function, we will get back the encrypted message. So regarding to XOR, please have a look into the cheat sheet, because we will encounter XOR a lot, and I have mentioned the whole operation in this cheat sheet, because it's really important. All right. So now we know our v0 contains the string we want to print out. The only thing we have to do is we have to insert the print out statement over here. And this is what we're going to do right now. So I clean this up real quick and now let's have a look. So normally I would take out my cheat sheet and have a look in how an system out works. But regarding to our slides, let's try to reconstruct this a little bit. So we know if you want to use system out, we have to first get the object reference, and this is done by asGetObject. Okay, afterwards we need to invoke the method println. Okay, so here we are fetching the object system out, and then we are using println, which ends up in system.out println. Let's try to get these information together with the things we know. So therefore we open up the cheat sheet, not the system out cheat sheet, the Dalvik opcodes cheat sheet, and we're looking for asGetObject. Okay, reads the object reference field identified by the field ID into Vx. Okay, so we are having a reference field which is being identified by the field ID. Yes, absolutely helpful, isn't it? So let's see. We simply copy paste this command over here. We have to take care about the registers, but okay, this one is clear right now. We have to put this object into a register. Now let's see how we can get the field ID. And therefore we take a look at the official Android developer guide regarding to system out. All right. Okay, so if we search for Android developer system.out, we have the Stack Overflow entry, which I already clicked, of course. Then we've got another Stack Overflow entry, and we've got the developer reference. In this case, we use this one over here because this is regarding to the system reference. Okay, so system is from Java lang system. This is important because we need this type reference for our object. Let's note this down. Okay, so maybe let's write this underneath. asGetObject, our register, and then we are using this reference over here. Yes. And now we want to access a field ID. So therefore we have this arrow and this field ID, let's see. This field ID, can we find this here? Yes, we have fields out. So this is exactly what we want to have. System.out. Out is from public static final print stream out, the standard output stream. This stream is already opened and so on. Okay, so we need the type reference of out also, because system can have more than one out, but we are looking for the print stream out. Therefore, to get this type reference of out, we click on print stream. It's loading. There we go. And now we know this is from the type Java IO print stream. Okay, so we copy paste this one. So we want to get the field ID out, and this one is from type Java IO print stream. Therefore, we just need to add this app. And that's it. This is how we can get the field ID from system.out. Okay, so this one here does system.out. But now we need to take care about the registers. So we can clean this out. Okay, now let's have a look at the registers. So let's see. We've got 3 local registers, which means we are having V0, V1 and V2. All of them gets used beside V0, but we need to keep V0 because this is our string we want to use. Therefore, we cannot override it over here. This means if we want to keep the code underneath, which we want to, then we do not have any other options than introducing a new register. But that's not a big deal. How can we do this? Yeah, let's go back. So instead of having 3 local registers, we are having 4 right now, and that's it. Now we can use the additional register we have created, which is V3 in our case, for example. All right. And yeah, that's all about this line over here. So let's recap this real quick. We have our system.out field, which gets identified by this type reference system. And here our out field is from type Java IO print stream. And we put this into V3. This means system.out is now being stored in V3. We can get these information, these type references, from the official documentation over here. So if we go back, here we are in the system reference. And system is from Java lang system. And the out field is from type print stream. If we click on this, we can see print stream is from Java IO print stream. And we have to be precise on this, which fields we are using. Therefore, we have to add the exact type references over here into our code. Okay, one last thing. We need to close this one here. Yes, now we've got it completed. This semicolon means this is the end of the type reference. All right, now we've got the syntax correct. So let's see. The next one we want to call is print line. Let's see how we can find this information. So we get back into this developer reference. Let's see, maybe we've got it already here. Yes, there we go. Print line is a method which gets overloaded with different arguments and parameters over here. We are looking for string, this one, print line string. So we click on this. Okay, print line is a public void method and it doesn't return anything, but it has a string as a parameter. Okay, so to call a public method, we need to have invoke virtual. Therefore, we go back into our opcodes over here. Invoke virtual. Invokes a virtual method with parameters. Okay, let's see. Now we have to take care about the this parameter. So here, the first one is our this object. In this case, it's system.out. And then we have the additional parameters in there. So let's copy paste this and insert it here. Okay, parameters. The first one is really easy because this is our system.out, our this object. All right. The next one is now our decrypted message, and this is being stored in V0 over here. So we also take this one as the first real parameter of this function. Which function? Print line. Therefore, let's get the type reference of print line. So let's see, print line, this one over here. And then print line. Let's click on this method. All right, and let's get back on top. Okay, so print line is from print stream Java IO print stream. This is our type reference of print line. So we need to copy paste this one. Okay, so now we want to call the following method. First, we have to add the reference of which type this method is. It's from Java IO print stream, therefore capital L, and the semicolon to signal the type reference has ended right now. Then we need this arrow and we need to call print line. Print line returns void. Let's check this. Print line for string, yes, it returns void. And here we have now our parameter. And our parameter is v0. And v0 is from type, let's see, Java lang string. So we simply take this one over here and add it as this parameter value. Okay, now everything should be set up correctly. Let's see. We've got our asget object. We are getting the field ID out, which is referenced by Java lang system. And this field ID is from type Java IO print stream. We get this into v3. Then we want to call the method print line. Therefore, we are using the invoke virtual on v3, which is our system.out. And now we want to call print line, which is from Java IO print stream and has a string as a parameter in there. Returns void. Okay, and this should be all. Okay, so now we've gone through this very detailed. And yeah, one hint is if you cannot find or if we do not deal with the official documentation functions. So let's say we want to call an internal function which has been created by the developer. Then we can also get these information within the JDX output. For example, this type over here, Java lang string. So within the imports, it might be not absolutely clear. But if we decompile this code, then we can take a look at the Smali code over here and see what type this object has. We can also look up existing objects and simply copy paste this type reference into our code. We have to make sure that we are using the correct one. And we will also do this here in some other examples later on. But I want to mention this right now, that it's not only working for the official documentation functions, it's only working, of course, for every other functions. Because Smali, unlimited power. All right? Okay, so let's see. We need to clean this off because this is not valid Smali code. And yeah, I guess that's it. Let's try compiling this app and see how it works. Okay, so now I see this error, and this error is super dumb because it's regarding to the copy paste. I was wondering why this is mentioned in blue. And the reason why it's mentioned in blue is we still have these dots in there. But Smali is regarding to directories, so therefore we need to replace these dots with slashes. So let's see. Okay, and I guess that's also what this error mentioned. So let's have a look. Error for yes. So at this point, I mean, the error message signals, okay, we do not have a .lang, .system, .io, .printstream, and so on. Therefore, we know, okay, we have to take a look into this. And yeah, if it gets marked as blue, because this is Java syntax right now, then you can directly see what's the problem here. All right. Okay, but nevertheless, I guess this is a really good example because we have seen if we make some really bad syntax errors, or at least I have done this, then the Smali compiler is trying to point this out at an error message over here. And then we can take a look into this and figure out what's the problem. If you copy paste this and you see a blue underlining here with Java syntax enabled on, then you can see it directly. So I'm not sure why I overlooked it that long, but yeah. I also make mistakes. All right, now let's see. We save this file. We try to build it back again. This one was the version without those two statements. Let's see if it's now working. Looks good. All right, the app has been built. That's a good sign, but it doesn't mean that our syntax is working. There could be an error that occurs while accessing those objects, and this is during the runtime. But building an app without Smali errors is a good first step. Okay, so let's see. Oh, the screen copy is not available anymore. Let's see. Okay, so it seems like we have lost the ADB connection. So let's get the screen copy back again. ADB connect. In case if you also encounter these errors, simply just restart the Android virtual machine, then we are good to go. Okay, let's keep this in foreground. So we still got our original version installed. Let's see, maybe we've still got the system out grep somewhere. Okay, there we have our system out grep. So yes, that's the original version. Let's uninstall this and see if our system out prints out the decrypted message. So let's see. ADB shell pm list packages. I'm not sure about the package name, so let's search for encrypt. Okay. ADB uninstall com. Oops, I need to go back. ADB uninstall com app hacking encryption. Okay, so the app should be gone. And now let's run the system out grep command. And here we are going to install our build version. Oh, it's not even signed right now. Yeah, we already have built this after making this error. So let's see. Okay, so here we have the destination. I have built and signed this app right now. Let's install it. This is our modified version. Okay, install test keys only, no problem. Okay, there we go. Here we have the encryption app. Let's open this and see. There we go. This is my secret message. This message is our decrypted version of what we have entered. Super nice, isn't it? Even without having root privileges or a debugger attached to this, we can print out the secret message. We can also print out the key, for example. And we can also verify that this message is correct. We can use this over here and we can simply, let me close this one, we can simply replace it with this one. So if we now build this app back again, we should get the encrypted version. Let's do this real quick. Okay, so here I have the new version already signed. Let's uninstall the existing one. Okay, let's install our new version. Still test keys. And this one now has our decrypted message as input of our XOR encryption method. So by opening this one, we can see, yes, we get back whatever is going on right there, but we get back our encrypted message text here. So super nice. This is how XOR works. We have an input, we XOR it with a key or a value, we get an output, and if we take the output, XOR it with the same key, we get back our input. Alrighty, so what I wanted to show is how you can write the system out on your own. And in case if we have some missing registers, we can simply introduce new ones. And by having this, you can print out whatever you like. Okay, sorry, maybe not whatever we like, because if we do not have a string in there, let's say an object, we need to figure out first how we can print out this object. But you guess what? This is what we're also gonna do in a couple of videos. Okay, so for now, that's all about the system out. I mean, we have coded this now on our own and we have seen how we can get the necessary informations to, for example, how we can fetch this information, that it's Java print stream and things like this. We have also seen a dumb mistake by me, which is having dots instead of slashes, but the Smali decompiler point us to the problem and I could figure it out what was the case. Alright, that's all for this challenge right now, but don't worry, within the next video we take a look into another challenge. So we have a lot of challenges right now. So I see you there.